Morse code, another timely topic, I must say, with the wet bulb globe temperature. What in the world?
I don't know what that is.
When you see
I feel
it.
like you're going to explain it.
I will. We had some extreme heat and humidity over the weekend. These were the heat index values from last Friday when a lot of us were near triple digits for the heat index, and that's combining the humidity and the actual air temperature. We can take it one step further, but first, heat index is so important because that's the temperature outside, how it actually feels to our body. The amount of moisture in the air, when that's very high, we can't sweat as efficiently. That sweat on our bodies can evaporate into the air because there's a lot of moisture already in the air. But again, we can take the heat index a step further with the wet bulb globe temperature. You might not have heard of it before, but it's a very valuable index that takes into account more variables to determine how it actually feels outside. So the wet bulb globe temperature is a measure of the heat stress in direct sunlight. That's the key here because the heat index is measured in the shade with that thermometer and the relative humidity percentage. The wet bulb globe temperature is measured in the sun, so it's a better indicator of that sun beating down on us. It uses the temperature, the relative humidity, and it also incorporates wind, cloud cover, and the sun angle. So when the sun's a lot higher in the sky in the middle of the day and into the afternoon, the wet bulb globe temperature is going to be higher, and it's going to tell us the heat stress level is a lot higher, and we're going to have to take more frequent breaks. So this is the calculation for the WBGT. 10% of it is just your air temperature measured with a normal thermometer. 70% of it, so a large chunk of it, is the wet bulb temperature. And that is with a sock on the bulb, the bottom part of a mercury thermometer in a real sense here, and that simulates the cooling effect of our sweat. And think of that as the sock or the wet part of that thermometer. That has to evaporate into the air, and the more moisture that there's in the air, the less effective that's going to be. Again, the more moisture that's in the air, the more humid it is, the less effective we are at sweating. So that wet bulb temperature is really important here. And the actual definition of wet bulb temperature is the lowest temperature to which the air can be cooled by evaporating water into it. So let's say here's the dew point temperature, and here's your air temperature. As it rains, the water from the rain evaporates into the air. That cools the temperature, rain-cooled air, and increases the dew point to get to our wet bulb temperature when the dew point and the actual temperature meet. So again, the wet bulb temperature is a big part of this WBGT equation. The remaining 20% is the black globe temperature. That is a hollow copper sphere painted black. So, there's a thermometer at the center, and that accounts for the warming effect of the solar radiation. It simulates how hot it feels in direct sunlight. So when you add all of these up, including the wet bulb temperature, just your standard air temperature, and the black globe temperature, that's how you get the wet bulb globe temperature. So simulating that direct sunlight, simulating how our bodies respond to sweat when there's a lot of humidity in the air. So it was invented in the early 1950s in response to a high number of heat casualties in the U.S. Armed Forces. From 1942 to 1944, just in those few years, 198 soldiers died due to heat illnesses during training. So the military modified training sessions with the wet bulb globe temperature using that knowledge, and after implementing these policies, there was a drastic reduction in heat illnesses. And these Army and military training sessions used the WBGT in order to modify their training. And you can use a thermal environment monitor. That's that contraption here, but there's also some handheld monitors, heat stress monitors or trackers that you can get to measure the wet bulb globe temperature on site. And it goes on the scale here, the risk level, and it's generally between 80 and 90 is when you start getting a little bit concerned, and over a 90-degree WBGT level, that's when it's into the extreme level. So there's even some schools that measure the WBGT before and during athletic practices, and the military is using the WBGT because it's a measure of heat stress, and it's a much better indicator compared to just the heat index of how we are stressed in direct sunlight and incorporating those other variables like wind and cloud cover. So here's the scale here. Last Friday and over the weekend, we were in the elevated classification to maybe the moderate classification when the actions are we need about 15 or 30-minute breaks for every hour that we're outside. And once you get a lot higher on that scale, that's when it gets to the more extreme classifications. There's a little bit of an easier way to understand this on a map based that the National Weather Service came out with this year. It's their heat risk tool, and this is for today. Up and down the eastern seaboard, especially near the nation's capital, there is a high risk for heat-related illnesses because of high heat and humidity. There's heat advisories in place. So near DC today, the max heat index is 109 degrees, and the max WBGT, the wet bulb globe temperature, is near 88 degrees. That's in that high classification where 40-minute breaks every hour when doing work or exercise in direct sunlight is needed. So there's specific WBGT guidelines. They can vary based on different regions. Of course, in the south, they're going to be more adapted to the high heat and humidity compared to us. And these are specifically from the Corey Stinger Institute. And he was a football player for the Vikings who tragically died in 2001 from complications from heat stroke. So there's specific guidelines based on these institutes and based on the OSHA regulations and the military that come up with these regulations for how frequent breaks they should be taking based on those WBGT values. So that can look for work to rest ratios, hydration breaks, wearing equipment or not wearing equipment, football practice, getting into the summer and then the fall seasons. So school districts are implementing this. Specifically in Georgia, they're mandating all high schools to measure the WBGT before and during practices to keep students safe. So here's the scale. Again, 80 to 85 is when your body is being stressed after about 45 minutes, and you get into that moderate and high classification. Over 90-degree WBGT is extreme, and that's when our body is stressed only after 15 minutes in high heat and humidity. So let's go through a couple of examples here to wrap this up and to really illustrate the difference between the heat index and the WBGT. So the temperature is 95 degrees, dew point 72, but in 100% sun, the WBGT is going to be 88, compared to if there's some clouds and only 30% sun, the WBGT is 86. The heat index, though, is 104 in both. So again, with the WBGT, we get a little bit more fine scale resolution, some more information into that number. And then this last example here, temperature is 90 degrees, dew point 65 degrees, but with a wind of 13 miles per hour, that decreases our WBGT from 89 to 83. The wind helps us to sweat more efficiently, but again, in both examples, the heat index is 92. So with the WBGT, we can see the other variables being incorporated into that index, wind, cloud cover, and most importantly, the direct sunlight and how that impacts our bodies.
It's dangerous.
It is dangerous.
Yeah.
So one really important question, do you like relish on your hot dogs?
I'm not a relish fan.
We have
I'll
a treat
take all the
for
ketchup.
you, Jacob.
That was a
Jacob
really
gets
good
his hot
segment,
dog. Yes,
so,
thank
yeah.
you, Jacob.